Hey guys, and welcome back to this week's video. And this week I'm going to be doing something a little bit more different. In fact, I'm going to be answering a question that you might have wondered or might not have wondered about, but this is a very important thing to understand, especially when dealing in calculus. So I'm going to focus on what is dx, or what is the notation of dy over dx, and what is it and how do we treat it. And you might think, oh yeah, let me just treat it as notation, but that's not really gonna work out for you as you go further on, because then you're going to start wondering, well, why do I have a dx here? Or for example, why is it d squared y but dx squared? And for some cases, we even treat d dx almost like a fraction where we cancel them out. And you might be kind of confused on how that works. And in order to help you, I'm going to explain to you what is d over dx, or just dx by itself. Well, to start off, basically, the d in front of the x or the y is representing a very small change. It's infinitely small. It's like an instantaneous change. You have, what do I know, a line, and you can have a large change, or let me do this in black, a large change, and then you can have a change, get smaller, 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 and what that dx or dy says is that you have an infinitely small change in x or an infinitely small change in y. So this is a differential. Differential in the sense that it shows the difference between 2 points. For example, the difference between x1 and x2. Now, let's look at this on the graph. So basically, dx represents this, the change in x, while dy represents this, the change in y. From this point up to this point is dy, and from this point up to that point is dx. Change in x, change in y. And why do we have this notation of dy over dx, or d and then you write in your function over here over dx? Well, because if you think about it, what is the slope? As we have seen right over here, the slope is your change in y over your change in x. That's very basic definition. And what the d is saying is that you have an instantaneous change in y over instantaneous change in x. So you have the slope at that exact infinitely small moment. And this is what this right here is pointing at. It's basically the slope between the instant change in y versus the instant change in x. Now let's focus on a second example, the example with the integrals. So when you write integrals, you have the notation of the integral of f of x with respect to x, right here. But where does this actually come from, and why do we have that dx at the end? Because viewing it as just notation isn't going to get you much conceptual understanding. Well, first of all, what is an integral? Well, an integral, as you might have known, is you want to find the area under your graph. So you're taking all these areas and you're adding them together, right? You have this times this, and you add all of these rectangles together, right? This is like your Riemann sum, for example, or your approximations. And if we look at this, what does this notation, how does it link back to these rectangles? Well, if you think about it, each of these rectangles has its own area. And how do we find that area? Well, this is going to be our width, and this is going to be our length, or the other way around, however you want to call it. And our length or width, in this case, let's call this the width, is dx. And our height is f of x, if this function is f of x. Right? Because this is the value of the function, that's the height. And the width is going to be this instantaneous small change in x, because remember, we want to have these smaller and smaller and smaller rectangles so that we're getting a better approximation to a point where it's exactly the area. So basically, this point right here, this part right here, is giving us the area of a single rectangle, where this is, for example, the height or the width, and this is like the length. But what does this symbol over here mean? Well, this is just a summation symbol. Don't forget that this integral symbol is just a summation symbol. So we're adding all of the areas that we have found right here together. as we have seen over here. We're adding all of these areas to get the area for this right here. And once again, what is area? Area is length times width. And in this case, our length right here is dx, and our width is f of x. And that's it. So I hope you have understood this a bit better, why we have a dx, what this symbol actually means, and for example, in dy over dx, what does this mean? And for example, you will find this very useful later on when you're working with, for example, differential equations or other aspects of calculus, and you have to work with this notation, because this notation isn't only going to be there for you to find the derivative or the integral. You're going to have to manipulate these expressions, and in order to do that, you're going to need to know how to work with dx or dy, and in order to do that, you have to understand what this actually means. And basically, what it means is this very small instantaneous change. So I hope you enjoyed. I hope you now see where the dy over dx comes from, or where the integral comes from with the dx at the end. And see you next week.